Good morning, everyone. I'm Dhruti from Sri Venkateshwara College of Engineering, CSCI Department, Bengaluru. Today, I will give a small presentation on implement and demonstrate Q-learning algorithm. Let's move to the introduction. Introduction. Reinforcement learning is an interdisciplinary area of machine learning and optimal control concerned with how an intelligent agent ought to take actions in a dynamic environment in order to maximize their cumulative reward. So the basic components which involve here are the agent, environment, actions, and rewards. A reinforcement learning model has four essential components, that is, a policy, a reward, a value function, and an environment model. So we can tell that this is not only an machine learning thing, but also it includes the reinforcement learning. So the main components which includes here are the agent, environment, actions, and rewards. And also four mainly essential components which involved in this reinforcement learning model are the policy, reward, value function, and environment model. So Q-learning overview. Explanation of Q-learning as a value-based reinforcement learning algorithm. Q-learning is a model-free of policy reinforcement learning that will find the best course of action given the current state of the agent. Use of Q values to iteratively improve the behavior of the agent. Q-learning uses Q values to represent the expected cumulative award of taking a particular action in a particular state. This is about the Q-learning overview. Then we move to the Q table. So first, building a table of Q of S, A values. So the Q table is a lookup table where we include maximum expected future rewards for action at each state. Initialization and update of Q values based on the agent's experience. To learn each value of the Q table, we use the Q learning algorithm, which involves an iterative process of updating and the values based on the agent's experience. So here this Q table involves a table of Q of S, A values, and you're going to calculate the maximum expected future values for each of the action which has been taken at each state, and you're going to update these Q values based on the agent's experience till now, and then you're going to learn each of the values from the Q table. So therefore, iteratively, you're going to update the values based on the agent's experience till now. Then, basic Q learning algorithm. Description of the key steps in the Q learning algorithm. Q learning is a model-free reinforcement learning algorithm to learn the value of an action in a particular state. It does not require a model of the environment and can handle problems with stochastic transitions and rewards without requiring adaptations. And exploration and exploitation phases. The Q-learning algorithm involves a balance between exploration, that is, trying new actions, and exploitation, choosing actions based on current knowledge to find the optimal policy. Then we go to of policy learning. Explanation of Q-learning as an of policy algorithm. Q-learning takes an off-policy approach to reinforcement learning, aiming to determine the optimal action based on its current state. The agent's ability to learn Q values regardless of the policy being followed. Q learning allows the agent to learn Q values independently of the policy being followed, which contributes to its robustness and flexibility. Then we go to Q learning example. Step-by-step illustration of the Q learning process in a simple environment. A Q learning example can demonstrate how an agent learns to make decisions based on the Q values associated with different actions in various states. Initialization, action selection, and Q value updates. The Q learning process involves initializing the Q table, selecting actions, and updating Q values based on the rewards received. Then we go to the convergence and optimality. Discussion on the convergence of Q learning. Q learning aims to converge to an optimal policy by iteratively updating Q values based on the agent's experience and the rewards received. The goal of maximizing the Q value to find the optimal action selection policy. The ultimate objective of Q learning is to maximize the Q value for each state action pair to determine the optimal action selection policy. Then we move to the applications of Q learning. Real world applications of Q learning, such as game playing and robotic control. Q learning has been successfully applied to various real world problems, including game playing, robotic control, and optimization tasks. Success stories and challenges in applying Q learning to complex problems. While Q learning has shown success in many domains, it also presents challenges such as scalability to large state spaces and complex environments. Thank you.